Now I would like to show you a case of an improper integral that is divergent even for finite limits a and b. Consider the integral from 0 to 1 of the function 1 over x dx. In the full notation, the problem point is 0, because at 0 the function does not exist. So we don't integrate from 0 but rather from a to 1, and then we consider the limit for a approaching 0 from the right, from inside. And copy the function 1 over x dx. Now we find the antiderivative, so we have limit for a approaching 0 from the right, logarithm of x from a to 1, which is limit for a approaching 0 from the right. Logarithm of 1 is 0 minus logarithm of a. But as a approaches 0 from the right, logarithm goes to minus infinity, and minus logarithm goes to plus infinity. In the short notation, this would read 0 from 1 over x dx is logarithm absolute value of x from 0 to 1, at 1 logarithm is 0, and at 0 plus this is minus infinity, so this is plus infinity. Well, you see, now we have a little problem. This is not just ordinary 0. This is just an abbreviation of this notation. A goes to 0 from the right. To improve this, we might write 0 plus to stress that we need a single-sided limit. Well, this is well illustrated by the graph of the function. The integrated function 1 over x has the graph, namely the hyperbola, and the integral has the meaning of the area of this region, which is unbounded and has unbounded area. This tail is so thick that the area is infinite.